Hello students and welcome to my channel Maths Hub. So in this video, I'll talk about logical equivalence. Now whenever we talk about compound propositions, we never say that the two compound propositions are equal. It might happen that you are working on two different compound propositions and they are giving you the same truth values, but they don't mean that they are equal, right? So in that case, when they are not equal, what word we use for it? We say that they are logically equivalent. Why logically equivalent? Because they are giving you logically the same truth values. So whenever two compound propositions give you the same truth values in all the possible cases, then those two compound propositions are said to be logically equivalent, right? So we need to show that negation P or Q and P implies Q are logically equivalent. Now, how do we prove this? Now, we can prove this with the help of the truth tables, right? So this is one statement and this is the other statement. So we will not prepare two different truth tables. We will prepare the truth tables in both the truth tables in one truth table only, right? So for both the statements, what are the requirements? We require P, we require Q, we require negation P, we require negation P or Q, and we require P implies Q, right? So now both the statements can be false. One of them can be true and false, or both the statements can be true. So what is negation P? Whenever P is false, it is going to be true, and whenever P is true, it is going to be false, right? Now what is negation P or Q? True or false is false. False or false is, sorry, true or false is true, right? We are going with the or operator. So false or false is going to be false. True or true is true. True or false is true. Now what is P implies Q? False or false is true. True or false is false. False or true is true. True implies true is true. So now check these two tables, these two columns. Are we getting the same truth values in all the possible cases of P and Q? Yes. So in this case, we say that not P or Q is logically equivalent to P implies Q. So this is the symbol for logical equivalence, right? So we say they're not equal, but they are logically equivalent to each other, right? Okay. So let's check another example. So in this example, if I draw the truth table, I have P, Q inputs, then we have negation P, negation Q, then we have P and Q, then we have negation P and Q, and then we have negation P or negation Q, right? So the values are already filled. So you, without checking this table, you can draw your truth tables and you can cross verify that whether you are getting the same truth values or not, right? So once you have prepared the truth tables, you can easily check the last two columns. The last two columns are our required results. And you can see that both the columns are giving you the same truth values irrespective of whatever input you took, right? So these two statements are logically equivalent, right? Here, done. So there are many more exercise problems to do. It's very simple. You just have to prepare the truth table and then comparing the last two columns, you can decide whether they are logically equivalent or not, right? So I've given you some questions to do, although the answers are given in the slides, but I would recommend not to check the answers and do it yourself and then check the answers, right? So this is your first exercise that you need to do. Answers is given, right? Then this is the second exercise. So you need to check these two exercises, whether P implies Q is logically equivalent to negation P or Q. And similarly, P or Q and R is equivalent to P or Q and P or R. So do them and then check the answers. The answers are given here, right? And then check the next exercise. You need to prove the biconditional equivalence, negation P by equivalence by conditional statement Q is logically equivalent to B P by conditional statement negation Q. And again, the answer is given here, right? Okay. So thank you so much for listening to me. And if you like the video, do hit the like button. And those of you who haven't subscribed my channel, so it is your first job to subscribe the channel, right? And believe in yourself, and you will definitely succeed. Thank you so much, and have a nice day.